Now position and time graph, we are taking position and time graph. Position and time graph. Position and time graph. This is x and this is time, isn't it? Position on the y-axis, time on the x-axis. Position on the y-axis and time on the x-axis. Now, for example, see here, my position is, I am standing at this position. If you see the time, after 1 second I am standing here, after 2 seconds also I am standing here, 3 seconds also I am standing here. See here, the time is, with respect to the time, what about my position is at rest position. See here, according to this one, time is 1 second, 2 seconds, 3 seconds, 4 seconds and so on. My position is initially is here. So at 1 second my position is here, at second my position is here, third second is my position is here, fourth second also my position is here. Line joining all the points, it is nothing but a resultant curve is like this. So the resultant is parallel to the x-axis. When resultant is parallel to the x-axis in the position time graph, now the object is at rest position. The object is at rest position. Object is at rest position. And next one, if you take position same again, because we are explaining about the position time graph. Now position on the x-axis, y-axis, time on the x-axis. Now the resultant I am taking like this. If the resultant if I am taking like this, at that moment the object is nothing but the slope can be gives uniform velocity or speed. Uniform velocity or uniform speed, it can be represented. Means in this situation, what is the slope means? Slope is nothing but slope is equal to, we can write it is y2 minus y1 divided by x2 minus x1. The difference between the 2 points on the y-axis divided by difference between the 2 points on the x-axis. So y2 minus y1 divided by x2 minus x1, that we can give it is nothing but a uniform velocity. Now this graph we can take in this. See here, initially the position is rest position. Actually from the second equation of the motion, how we can write means x2 minus x1 is equal to x2 minus x1 is equal to ut plus of at square. Here initial position is at rest position and finally it is having having x2 position, for example. So x1 is equal to 0, x2 is equal to this equation you can write as a ut plus of at square. Initial position is x1, initial position is 0. So at that moment x2 is equal to ut plus of at square. But when the graph it is comes like this, isn't it? That slope is nothing but a uniform velocity or uniform speed. Next one I am taking here position and time graph. Position and time graph with increasing slope. I am giving it is the increasing slope. When I am giving increasing slope like this, it is nothing but a uniform acceleration. It can be gives represents the uniform acceleration. Uniform acceleration, increasing velocity, we can give it is nothing but a uniform acceleration. And in this situation also, x1 initial position is at rest position. We can write it in this situation also, s is equal to x2 is equal to x1 minus x0 is equal to ut plus of at square. x2 minus 0 is equal to ut plus of at square. And if you take same curve like this, position and time, and like this effect, this is also increasing, but it is started with the position is 0, initial position is 0, but it is not initial position is 0. Here x1 with the initial position x1 it is started. When it is started at this position, that is initial position is 0, but here y intercept is there. So at that moment we can write it is initial position is not equal to 0. That equation you can write as a x2 minus x1 is equal to ut plus of at square. X2 minus x1 is equal to ut plus of at square. And decreasing slope. How we can draw the decreasing slope means the position time. Position time if you taken like this. This is decreasing slope. It is increasing slope and it is a decreasing slope. And this decreasing slope is nothing but a retardation. Uniform retardation you can give. Uniform retardation. Uniform retardation. So here increasing velocity we can call it is acceleration. Increasing velocity we can call it is acceleration. We given already when I explained the acceleration topic, I given the example also at that moment. Increasing velocity is called nothing but a acceleration. Decreasing velocity we can call it is nothing but a retardation, or negative acceleration we can call it is retardation or deceleration. Negative acceleration we can call it is retardation or deceleration. So it is uniformly decreasing. So that's why we are calling it is uniform retardation. Velocity time graph. Velocity time graph we are discussing. Now velocity on a y-axis, time on the x-axis. Just I am writing here velocity and time on the x-axis. Time on the x-axis, isn't it? Now I draw one line like this. Slope. What about the slope can be gives already given. Slope means you have to keep in your brain every time. Slope is nothing but a y-axis divided by x-axis. Y-axis, what is the y-axis? Velocity. And what is the x-axis? Is the time. Velocity by time is nothing but a rate of change of velocity is called acceleration. So slope gives the acceleration. Slope is nothing but a acceleration. Slope is acceleration. Slope is acceleration, and it is uniform acceleration. Slope is nothing but a uniform acceleration. Slope gives the uniform acceleration, isn't it? And it is increasing velocity. It is always increasing velocity. This meaning is nothing but a increasing velocity, and it gives the uniform acceleration. And what is the initial velocity here? The curve is started from the origin. The curve is started from the origin, and final velocity is at this position. Final velocity, this is velocity. So final velocity is v. At a time interval is t. At a time interval is t. And here it is initially 0, 0. Velocity is 0, time is 0, isn't it? So we can write it is initial velocity of the object is 0. Final velocity is final velocity is nothing but a v. Final velocity is equal to v. In a time interval, time is equal to t. From the equation v equal to u plus at. From the equation v, first equations of motion, v equal to u plus at. Here initial velocity is equal to 0. So that equation you can get 0 plus at. So v equal to at. This curve represents is nothing but a final velocity of the curve v is equal to at. And the slope gives the uniform acceleration. The slope gives is nothing but a uniform acceleration. And next curve, if you take in, next again, velocity on the y-axis, isn't it? Time on the x-axis, and what is the meaning like this? If the resultant is parallel to the x-axis, for example, see, I want to give one example here. When you are going by the bike, or car, isn't it? Whatever it may be, just you see the speedometer. If it shows first it is showing at that moment 50 km per hour. It's showing it is 50 km per hour. After 2 seconds, if you observe, it is first second, you observe it is the speed of the car is nothing but. What is the speedometer? A speedometer is a device which can measure the speed of the car or speed of the vehicle, instantaneous speed. So that is called speedometer. At first second, when you observe the speed of the car, it is 50 km second. After 2 seconds or 3 seconds, again you observe, After 2 seconds, you observe the vehicle, the speed is again 50 km per hour. After 3 seconds, after 3rd second also, the speed it is 50 km per hour, and after some 4th second also it is 50 km per hour. Coming to here, this is 10 km per hour, 20 km per hour, 30 and 40, and this one it is 50 km per hour. First second, what is the speed of the vehicle? What about the velocity of the vehicle? Speed is nothing but, I am saying here speed. Speed means does not having the direction. If I am giving, you are going towards the north direction, that is nothing but your vehicle speed is 50 km per second towards the north direction, that is nothing but a velocity. But your vehicle speed is 50 km per magnitude is nothing but a speed. If I give the direction also, that is velocity. So if I use the speed or velocity, that I am saying it is nothing but a magnitude here, isn't it? Because speed is a scalar quantity, velocity is the vector quantity. Now 1 second 50 km per second hour, and second also it is 50 km, 3rd second also 50 km, 4th second it is 50, 5th second also 50 km per hour. See here, the object is your car is moving with a uniform velocity. That meaning is nothing but your car is moving with a uniform velocity, isn't it? So this meaning, when velocity on the y-axis, time on the x-axis, if the resultant is parallel to the x-axis, that meaning is the object is moving with a uniform velocity. Object is moving with a uniform velocity or uniform speed. The object is moving with a uniform velocity or uniform speed. And next one, I will take like this. Velocity on the y-axis, again velocity on the y-axis, time on the x-axis, Now what about here? According to this one, we have to give the formula like this. See here, uniform velocity means here initial velocity is equal to final velocity. Your initial velocity, and at first second your velocity is 50 km per second. At the end of the 4th second your velocity is 50 km per hour. So initial velocity is equal to final velocity. What is the acceleration of the object at that moment? Acceleration of the vehicle. When object is maintain uniform velocity, acceleration is equal to 0. Means, what is acceleration formula? V minus u divided by t. Here initial velocity, final velocity is 50. Initial velocity is 50. So 50 minus 50 is equal to 0. 0 by something is equal to 0. So acceleration of your vehicle is 0. From the equation V equal to u plus at. From the equation V equal to u plus at, acceleration is 0. So V equal to u, you can write, that is V equal to u. Initial velocity is equal to final velocity. When object is maintain uniform velocity, at that moment initial velocity is equal to final velocity. So acceleration is 0. Okay. Next one, velocity and time graph. Again, velocity and time graph I am taking. If the curve is coming like this, means it is y-intercept is there, the slope y-intercept is there. At that moment the initial velocity is not equal to 0. But it is uniform velocity. So initial velocity is u, final velocity is v. In a time interval t. Is t. V equal to, you can write u plus at. This equation represents v equal to u plus at. See, in this situation, initial velocity is 0, but here y-intercept is there. Here initial velocity is not equal to 0. V equal to u plus at. Now, like this I am writing here. Isn't it? Here, what is the meaning of this one? Means, I will take one example here. See, in my hand, one chalk piece is there. Is it going upward direction? it's not going without any external force. It is not going upward direction without any applying external force. If I give the some external force, see here, if I give some external force, it is going upward direction like this, again coming downward direction. It is going upward. So I am discussing about going upward now initially. So when it is going upward direction, when object is going upward direction, what is the velocity? Gradually decreases or increases? When it is going upward direction, gradually it is decreases. Velocity is decreasing. Velocity is decreasing. See here initial velocity is more. Initial velocity is more. Then velocity is gradually decreasing and it is coming finally attain the velocity is 0. It is finally attains the velocity 0. See here, initial velocity. What about now initial velocity is 0? If I give some velocity to the object only, it can go upward direction. It will go upward direction. So I am giving some velocity like this. Just I given like this. So the object is gradually going upward. When object is going upward direction, its velocity is decreasing. When velocity is 0, it fall down. When velocity attains 0, it attains the velocity equal to 0, it will fall down, isn't it? So I am writing here, the velocity is gradually decreasing and it attains the velocity, final velocity is 0. Here this is initial velocity and this is final velocity is 0. We know equation v equal to u plus at. V equal to u plus at. Here final velocity, this is the final position. The final position along the y-axis is nothing but a 0. And u, initial velocity u plus at. You can write u is equal to minus at. See here, velocity is gradually decreasing. I told you just now only, increasing velocity we can call it is acceleration. Decreasing velocity we can call it is retardation or deceleration, negative acceleration. See here, u is equal to minus a, we got it. So minus a is nothing but a negative acceleration, we can call it is retardation. Negative acceleration we can call it is retardation. So we can get u is equal to minus 80. Okay, next one, actually this what I am going to explain now, this one in 2017 JEE Mains they asked, it is in your NCERT book also. This question in your NCERT book also. Velocity on the y-axis, time on the x-axis. Velocity on the y-axis, time on the x-axis. Now the graph I am giving like this. I am giving like this now. See here, it is going along this direction. It is going along this direction. What is the meaning? What is the meaning? What is the meaning means, again same problem. The object is going upward direction. Then after, first I am getting, object is going upward like this. See here, it is having initial velocity, maximum initial velocity. The initial velocity is gradually, the velocity is gradually decreasing. When object is going upward direction, its velocity decreases. Here, while object is going upward direction, velocity gradually decreasing. When it is attains maximum height, its velocity is 0. Again, when velocity is 0, it fall downward direction. With increasing velocity. See here, from here, in the negative direction, it is velocity is gradually increasing. See here, the direction is initially going upward, and second situation, when it is falling downward direction, the direction is downward direction. See here, it is in the positive and it is in the negative. The direction also changed here. So when object is falling downward direction, the velocity is gradually increasing. For your understanding, this is 1 meter per second, this is 2 meter per 4 meter per second, this is 7 meter per second, and this is 10 meter per second, and this one it is 13 meter per second. Initially, the gradually velocity is decreases. In the negative direction, minus 1 meter per second, minus 4 meter per second, and this is minus 7 meter per second, minus 10 meter per second. See here, gradually the velocity is increasing. So this is 2017. In JEE means they asked this question, isn't it? When object is, what they asked means, when object is projectile upward direction, which graph is suitable? They given 4 graphs. So in that one, this is the correct. So this is uniform retardation. See this one and this one, it is nothing but a uniform retardation. These two can be represented uniform retardation. V is equal to U minus GT. It is. These two equations can be represented. V is equal to U minus GT. In this situation also, we have to write object is projectile upward means this is nothing but a G will become. Object is projectile upward direction means that is G will become, isn't it? When it is horizontal direction, you can write as a A. When it is horizontal direction, you can write as a A. But vertical direction, this A you have to write as a G. Isn't it? And in this situation again, once again, I am giving conclusion. Velocity time graph, if I am taking the slope, the curve it is like this means the slope is nothing but a uniform velocity. The slope can give V equal, that equation V equal to U plus AT. Here initial velocity is 0 because it is started from origin. So initial velocity is 0, final velocity is V. Next situation, when resultant is parallel to the x-axis, in the velocity time graph, at that moment that is uniform velocity. Equation is initial velocity is equal to final velocity. Next one, I am taking it is the intercept, y-intercept. Y-intercept means the curve it is going like this. Here initial velocity is not equal to 0. It is having some initial velocity. When curve is started at this position, initial velocity is 0. But here y-intercept is there. It is initial velocity is not equal to 0. So that equation V equal to U plus AT you can write. And in this situation, negative acceleration. Velocity is gradually decreasing. When it reach here, final velocity is 0. So final velocity I written 0. U is equal to U. And it is negative acceleration can be represented. Here A is nothing but a negative acceleration, isn't it? And this is uniform retardation. It is represents uniform retardation. And in this situation also, it is also uniform retardation. I given this example is nothing but a object is once. From here to here, object is going upward direction. From here to here, the object is moving downward direction. This is also uniform retardation equation. Acceleration due to gravity. What is acceleration due to gravity? See here, I give one example. One object is when I leave this object, it is falling downward direction under the influence of the gravitational force. See here, an object accelerate towards the center of the earth. An object is accelerate towards the center of the earth under the influence of the gravitational force. That acceleration is called acceleration due to gravity. See here, just now I showed when you leave one object, it is accelerating towards the center of earth. Under the influence of gravitational force. That acceleration we are calling it is acceleration due to gravity. Acceleration is called acceleration due to gravity. That G value, G is equal to, you can write experimentally they calculated G is equal to 9.8 meter per second square. Acceleration we are calling it is G is equal to 9.8 meter per second square, isn't it? Now, under the gravity, if you take in the freely falling body situation, when object is freely falling, see here, this is one object and it is a ground. This is the ground. An object is without applying any force, I will take the chalk and I will show you, see here, without applying any force, the object is falling downward direction. Means here initial velocity of the object is 0. It is started from the rest position. When object is moving downward direction, when object is moving downward direction. Here velocity of the object is gradually increases. Velocity of the object is gradually increases. So I am writing here initial velocity u is equal to 0 when it is strike the ground. When it is strike the ground, it attains the maximum velocity. It attains the maximum velocity. That final velocity is nothing but a v. So according to this one, initial velocity u is equal to 0 and final velocity we are writing v, and how much distance it is traveled. How much distance it is traveled means this is nothing but a vertical displacement. When object is moving along the horizontal direction like this, when object is moving along the horizontal direction, we can call that is nothing but a distance or displacement. Distance covered by the particle or displacement covered by the particle, we can say it. But when object is moving up and down like this, the vertical displacement we can call it is height. Vertical displacement we can call it is the height. So this vertical displacement or distance we can call it is the height. So how much height it is traveled, that is nothing but a h. So s is equal to, we are writing h. Distance is equal to, distance s is equal to, I am writing it is h, isn't it? And acceleration a is equal to, acceleration is equal to g. I told you just now only I given definition. How I given the definition means, see here, when object is accelerating towards the center of earth, under the influence of the gravitational force. See here, object is accelerating. How it is accelerating? Under the influence of the gravitational force only it is accelerating towards the center. So that acceleration we are calling, acceleration due to gravity. So a is equal to g we are writing. So acceleration due to gravity also it is a vector quantity. So downward direction I am considering it is the positive. So because freely falling body, object is freely falling body, so the quantities initial velocity is 0, final velocity is v, and how much distance it is covered, that is nothing but a height h, and a is equal to h. Time, in a time interval, t interval, it is traveled from maximum height to ground, isn't it? So how the first equations will, the equations of the motions will be changed. Equations of the motion will be changed. Now coming to here, first equation v equal to u plus at. First equations of motion v equal to u plus at. What is the final velocity is? Final velocity is v. I am writing v only as you said. Initial velocity u is equal to 0 and a is equal to, acceleration is nothing but acceleration due to gravity, that is z, and time interval is the t. Time interval is the t. We can write this equation v equal to gt. I am writing this equation is nothing but a v equal to gt. V equal to gt. Next one, second equations of motion, s is equal to ut plus half at square. S is equal to ut plus half at square. Now s is equal to height, the distance. The distance s is equal to height h. So s is nothing but a h. Initial velocity is equal to 0. 0 into something is 0 plus half into acceleration. What is acceleration? Acceleration is nothing but acceleration due to gravity g we are writing. So a equal to g, that equal to t square. H is equal to, you can write half gt square. H is equal to half gt square. Now from this equation I can write the time equation also. T is equal to 2h by g. 2 I am taking this side, h if I take g also if you take this side, time is equal to 2h by g. What is this time means? Time taken by the body to reach the ground from this height. Time taken by the body to reach the ground. Just I drop the one object now. So that object, what is the time taken by the body to reach the ground? That is equation 2 is equal to 2h by g. If you know the height, you can calculate the time. So t is equal to 2h by g. Third equation. What about the third equation of motion? 3 v square minus u square is equal to 2as. v square minus u square is equal to 2as. Final velocity is nothing but a final velocity is the v. Here final velocity is v, and initial velocity u is equal to 0, and a equal to g, acceleration is equal to, we already taken place g, s is equal to h. So what is the final velocity attained by the object? V equal to under root of 2gh square. If I take in this side, it is nothing but a v equal to 2gh. See here, an object is falling down. This is the ground. This hand is nothing but a ground. One object is falling downward direction. When it is moving downward direction, it attains the velocity. When it is strike the ground like this, at that moment it attains the final velocity. That how much velocity it is attained, so that v is equal to under root of 2gh. And fourth equation of motion, Sn is equal to u plus a by 2 2n minus 1. Sn is equal to u plus a by 2 2n minus 1. Okay, S is nothing but I am writing h n, and u is equal to 0, a equal to g by 2, and 2n minus 1. So hn is equal to g by 2 2n minus 1. hn is equal to g by 2 2n minus 1 after substitution of these values. Okay, next we can take it is maximum. It is freely falling body. I explained about the freely falling body. Vertically projectile body we can discuss. Vertically projected upward. Vertically projectile upward. Now see here, an object is vertically projected upward direction. When object is vertically projected upward direction means, for example, see here, is it going upward direction with itself, by itself? It's not going upward direction. If you give some velocity, the object is gradually going upward direction. While when object is going upward direction, what about its velocity? Decreasing or increasing? When object is going upward direction, its velocity gradually decreasing. When velocity is zero, when velocity becomes to zero, it start to fall downward direction. Okay, so when object is going upward direction, at that moment initial velocity is u. Without giving of initial velocity, the object cannot go upward direction. So we are giving initial velocity is u. While it is going upward direction, velocity gradually decreases. When it is attains the maximum height, final velocity is zero. When velocity is zero only, at that moment the object will be come back again. So what is the height here? Height is nothing but a h I am writing. Height attained by the object is nothing but a h. Then after acceleration, first initial velocity u is equal to u, and final velocity is equal to how much? Final velocity, what is the final velocity? Is equal to 0. See here, when object is going upward direction, velocity gradually decreasing. Then after, when it is reach maximum height, that velocity will becomes to 0. So final velocity is 0, and distance is equal to, distance or displacement is equal to height. I told you, vertical displacement or vertical distance we can call it is height, isn't it? This is vertical distance or displacement, so that's we are writing as a height. Next one, acceleration. What about acceleration is equal to, see here, in this situation acceleration is equal to, we've written it is in this situation acceleration, when object is moving downward direction, acceleration is nothing but acceleration due to gravity plus g I have written, because acceleration due to gravity is a vector quantity. So when it is vector quantity means it is the downward direction. If I consider positive means when it is going upward direction, I have to write it is the minus g. I have to write it is the minus z. Then after, just we have to write time. Time is equal to t. Now again, first equation of motion, v is equal to u plus at. V equal to u plus at. What about the final? V is the final velocity. Final velocity is 0. Initial velocity is equal to u. U is nothing but a u only. A equal to acceleration, A equal to minus z. I am writing minus z, and time, this is t. Minus gt, if I take in this side, u is equal to, you can write gt. U is equal to, you can write it is nothing but a gt. Now here I am writing this t a is equal to u by g. This t I am writing as a t. When I am writing t as a ta, what is ta? Ta is nothing but a time of ascent. It is ta is nothing but a time of ascent. What is time of ascent means? See here, I will give the definition. Time of ascent. Time of ascent. What is time of ascent means? Time taken by the body to reach maximum height from the ground is called time of ascent. Time taken by the body. Time taken by the body to reach maximum height. To reach maximum height is called time of ascent. See in the diagram, from here to here, from the ground to height it is traveling. Time taken by the body to reach maximum height is called time of ascent. So the time of ascent Ta is equal to, we got Ta is equal to u by g. Time of ascent is equal to, we got it is u. Ta is equal to u by g. Okay. Next one, second equation of motion I am taking. S is equal to ut plus of at square. S is equal to ut plus of at square. What is S is equal to h? S is nothing but a h. U is equal to, initial velocity is u only, time is t, plus of a equal to, what is a here? Acceleration, a equal to minus z. So minus z I am writing, minus z, and this is t square. This equation you can write h is equal to ut plus minus into plus minus, so minus of gt square. This is second equation of motion. It is second equation of motion, isn't it? And third equation of motion, v square minus u square is equal to 2as. What is final velocity is 0. Final velocity is 0. I am writing u is equal to, initial velocity u is equal to u, that is equal to 2. A equal to, acceleration A is equal to minus z. S is equal to h. S is equal, distance is equal to h. Here minus u square is equal to minus 2gh. Both side minus get cancelled. You can write here u square is equal to 2gh. U square is equal to 2gh. Now from this equation I will define the maximum height. See here how I define. U is equal to gt. From u is equal to gt I taken Ta is equal to u by g. Here Ta I consider as a time of ascent. What is time of ascent? Time taken by the body to reach maximum height is called time of ascent. Ta is equal to u by g. So from this equation I am writing it is small h is equal to, I am writing it is maximum height. If I am writing, if h is nothing but a maximum height, if I am right at that moment, h maximum is equal to 2g. If you take this side, u square by 2g. This is maximum height. H is nothing but a maximum height. What is the definition of the maximum height? The maximum vertical displacement when object is projected, that is called, here a is minus z I taken. We got this equation. Next, third equation, how it changes? You got u square is equal to 2gh. I write h is equal to maximum height. At that moment, h maximum is equal to u square by 2g, because when object is projected, it attains maximum height. When When it reach maximum height, final velocity is 0. So maximum height is equal to u square by 2g. What is the maximum height definition? Vertical displacement of the particle is called maximum height. Vertical displacement of the maximum vertical displacement is called maximum height. Next one, fourth equation we got like this. Finally, time of descent. We are explaining time of descent. What is time of descent? Time taken by the body to reach the ground. Time taken by the body means here I told you, freely falling body situation, the time like this. Time taken by the body to reach the ground from maximum height is called time of descent. So this is freely falling body case second. So what about this time taken by the body to reach the ground? That is time of descent. Time of descent, we got it already. T is equal to under root of 2h by g. From this equation, Td is equal to, I written 2h maximum by g. Here h maximum, this value I substituted here. We got finally Td is equal to u by g. Time of ascent is equal to time of descent. Time of ascent is equal to time of descent. Time of flight. What about the definition of the time of flight? We already completed time of ascent, time of descent. What is time of ascent and time of descent? Time of ascent is nothing but a time taken by the body to reach maximum height, that is time of ascent. And time of descent is nothing but a time taken by the body to reach ground from maximum height, that is time of descent. So time of flight is equal to sum of the time of ascent and time of descent is called time of flight. So time of flight is equal to sum of the time of ascent and time of descent is called time of flight. And time of ascent formula is u by g. Time of descent is equal to u by g. Then you can write time of flight is equal to 2u by g. Time of flight